Geographic Information Council. If you're unfamiliar with that organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to know more on how to get involved with us, please visit our website, www.nsgic.org. I will pop that address into the chat box shortly. Just some reminders for our call today. All attendees have been muted on entrance. There will be time at the end of the presentation for Q&A. Please place your questions into the chat box to be read aloud at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for that email with the information. And now I will turn it over to Megan Ip, Senior Communications Manager of Ecopia, for our introduction. Thank you, Megan.
Thank you so much, Amy. So hello and welcome everyone to Ecopia AI's webinar today on our 3D nationwide land cover on-demand content. As Amy mentioned, my name is Megan Ip and I'm the Senior Communications Manager here at Ecopia. On today's agenda, we'll start with a very brief history of Ecopia, followed by an overview of technology and innovation. Then we'll go into our 3D nationwide land cover initiative, followed by use cases and comparisons, as well as a procurement model. Then we'll leave plenty of time at the end of the session to take any questions the audience may have. Now, without further ado, let's hear it from Brendan Palin, our Director of Public Sector and International Development. Brendan, over to you.
Thank you, Megan, and thank you everyone for joining. Really excited to be here today. This is a really exciting initiative that Ecopia has been working on for quite a while, and effectively you guys are the first community to really be hearing about it, as this hasn't been formally announced to the public yet. So with that, today we're going to explore a lot of really cool developments that Ecopia has been through. But before we kind of dive right into that, I think it's really important to start from the history of where Ecopia started to where we've been and where we're going, because I think that adds a lot of detail to kind of building some insights in terms of how we are able to develop this content. So I know I've spoken, with several members of this community, if not most members, who may be familiar with Ecopia, but to start off with, just to give a refresher. So Ecopia itself is a fairly young company. But when you consider the concept of artificial intelligence, especially within the geospatial industry, the concepts are relatively new in the sense that technology, before cloud computing really existed, it didn't make it very feasible to kind of leverage the true power of artificial intelligence. So we were started back in 2010. Our company actually spun directly off of a grant from some PhD research. And we focus primarily on extracting building footprints. And this is where we really got our feet on the ground, so to say. And we kind of developed we did develop a technology that was robust enough and built up such a large training set of data where we were able to scale that slowly and progressively to the point where in 2016, we accomplished our first countrywide extraction for the Australian government, where we extracted over 16 million buildings. And I apologize for our Americans here. We are Canadian-based companies, but it's close to 8 million square kilometers in area in 6 months. And I think it's important to consider that time as well, because it also provides some grasp in terms of how we've advanced our technologies as we progress through this. Moving forward into 2017 and 2018, we expanded this with the development of the extraction of every single building footprint across the USA. So similar area, however, you can see that we went from 16 million buildings to 169 million buildings in 6 months. So this just shows how quickly and how rapidly the technology has augmented. But more importantly, what we also found at this point is that we could leverage our technology to expand beyond just these man-made objects that we had previously been so focused on extracting, where we started developing and formulating a method or a path to be able to extract not just a standard land cover product, but a very high resolution product. Moving through that, we continued to iterate and continued to expand on the success of this, working with some of our partners who are here today and some who I'll talk about as we go through the presentation. And we moved more in terms of this advanced land cover, starting to talk about smart cities, transportation engineering, really moving into the planimetric side as we got more and more granular and more focused in terms of what we were able to achieve with our technology. And most recently, where we're at now, one of the largest projects that we did accomplish was mapping all of sub-Saharan Africa. Huge initiative in partnership with the Canadian government, the Bill and Melinda Gates Foundation, and Maxar Technologies. We're really excited about that. That's still in the midst of being rolled out, so I'm sure there'll be more and more news coming about that. But what we're really here to talk about is the development of the first US nationwide 3D high-resolution land cover map. And with that, that is where we're focused on in moving the future, building more content for users like yourself to be able to achieve, or access on-demand content. So when we talk about this vision of what we're building, I was fortunate recently to attend a webinar through the OGC where they talked about the integration of digital twins and the necessity of having all of this information reliably available in order to have critical decision-making skills. And this is exactly where we envision ourselves in the future as we continue to iterate. You've seen the growth through the company of where we started with building footprints, moving to land cover, moving to more planimetric detail extraction. And this is exactly where we're heading. And when we talk about developing this stuff as a product, it's essentially moving away from the concept of just having these built or tailored to one customer, but building it out for multiple groups so that everyone can take advantage of this data. And by having more people involved, you can lower the cost of the product. So when we talk about the different verticals that we're servicing, as you can see, Ecopia has done extraction over 100 countries around the world, working with groups ranging from NGOs, government, telecommunications, through insurance, just to name a few. Some of the largest players in the industry, some of the primary people who utilize geospatial data have leveraged Ecopia's resources to be able to achieve some very critical, some critical data landmarks for themselves. And I like to show this slide just because it puts things into a bit of perspective. So what you're seeing here is actually the building footprint data extracted across the US, Australia, and sub-Saharan Africa. And it kind of puts things into perspective of, although these data sets are so large, when you encompass it, you can already gain so much information just by looking at a picture. So as we continue to build this track record and the success around the world, we're really excited to continue to partner and leverage these skills that we've developed to continue to fuel data creation. So one thing that Ecopia always talks about, and it's very critical to even this presentation today, is our ability to form partnerships with other aerial imagery providers, satellite providers, street view providers, but also our end clients, so that we can build these solutions to ultimately meet a utility and a wide variety of end goals. And with that in mind, we always produce data sets that are not necessarily just one-dimensional. We try to achieve something that can be utilized across a wide variety of industries, as I discussed. So the technology, so we've discussed machine learning. I think it's been a topic of interest for many individuals and groups who are a part of the NSGIC community, especially when it comes to geospatial data. The power of machine learning, artificial intelligence, deep learning has become more of a topic of interest because it's enabling people to think about geospatial data differently than they previously would have. The power it enables is no longer do you have to think about one-time data creation over a period of 10 years. Now it's the ability, okay, as soon as we can get imagery, we can update, we can have on-demand data, we can have critical insights delivered and turned around within 24 to 48 hours. It's changing the way that we think about the industry. And Ecopia's machine learning and deep learning process is all proprietary. It's all been developed in-house. And as you've seen, we've scaled it to a point where we've become an industry leader. And a big part of that is the workflow that we've established, in the sense that all of our products are guaranteed to a certain accuracy, in which we generally consider to be over human level accuracy. The distributed human annotation approach leverages not just AI in the sense of doing an extraction, but also AI to guide where there's potentially errors or potentially needing an additional layer of QC. And by having that robust system built and that iterative process, we're able to continuously improve our workflow and therefore those results that we're delivering to our customers. So what we want to think about is, the concept of where we've been to where we're headed, what has been made available, and how can we take advantage of these different resources in the future. I think it's fair to say that when we talk about manual digitization, there's a standard or a level of trust that's achieved from having a professional who's trained in photogrammetry do data extraction. However, one could also make the argument that when you have multiple people doing a data extraction, for example, with natural features, their definition of what embodies a certain feature class could lead to errors in terms of classification. Similarly, with standard automated software approaches, you're going to achieve a level of 60, 70% accuracy, but realistically, it's not something that you can rely on for decision making, critical decision making consistently. And that moves into the concept of normalized data. And when we talk about large scale data extractions, one of the biggest challenges is being consistent. And what we're talking about today is data creation across the entire United States. So how do you provide a product that's consistent, not just on creation, but also on updating? And that's where our solution comes into be. Similar approach when we talk about the fast countrywide extractions. Obviously, price is critical. And as I mentioned before, when we create these products, what we're doing is we're achieving economies of scale by not just targeting one audience, but targeting a variety of sectors. Specifically in government, where this can be taken advantage of is a lot of our products are built, for the telecommunications, the insurance sector, but we're able to offer a unique licensing model to our government clients so that they can take advantage of lower cost models, and more importantly, be able to have access to that data and updated data in a predictable fashion. So to summarize in terms of Ecopia vectors, what we're putting forward is a model that achieves over 95% geometric accuracy, which is arguably considered to be over human level accuracy. It's a consistent normalized data set where all of our data sets are extracted on the exact same parameters. So no matter where that data is going to be extracted, it'll follow the same rules. When we talk about fast countrywide extractions, you already saw the timelines when we looked at the history. That's only progressing and excelling even further. And you'll see how quickly that will be as we talk about the US. So overall, there's kind of 3 points I want everyone to keep in mind as we progress through this. This presentation is the concept of accuracy, scalability, and up-to-date. Because I think these are the 3 pinpoints or the challenges that most people face from a geospatial background is how do you maintain these data sets? How do you actually achieve large scales of data extraction? And more importantly, how do you make sure that that accuracy meets the requirements you have internally to, one, continue to maintain the prerogatives that you're based on, but two, also guarantee that, sure, maybe this is leveraging a new technology, maybe there's some hesitancy, but if we can guarantee the same accuracy of what was previously done, then it takes away a little bit of that concern. And with that, I'm going to take a sip of water. It's because I'm the only one talking today. With that, I'm really excited to talk about the Ecopia 3D land cover data program. So this has been something that's been in the works for quite a while. And I think it's important to kind of pause and think back to our first NSGIC meeting back in 2018, where we discussed land cover as a service, how we were working with different groups, whether it was at the county level, we're doing different projects with NOAA, to now us expanding that solution to building out the full nation as a 3D data model. And with that, some of the key topics I want to highlight are the opportunities in terms of a new strategy for data creation, the partnerships that are available in the sense of, instead of it just being data created or procured through one group, it can now be procured through multiple groups using these derivative-based products from the foundational layer. A topic that everyone always asks about is change detection and updating and how we'll be able to service that model. So I made sure to include that. And then obviously some additional use cases, and we can explore. I put forward a granular demonstration of how a local government is using it, and at the high level, how federals are using it. So when it comes to geospatial data, and when we think about creating these large scale data sets, it's very important for us to take, a holistic look at who's using this data, what is the power behind that data, and thinking about geospatial solutions, not just as a product, but something that could have a measurable economic impact. And through that, we wanted to build a relationship and partnership that would enable us not just to be able to collect that information and build out the content, but more importantly, allow us to have a stable model of data creation for years to come, and something that could be relied on not just now, but also 3-5 years from now, and progressing even further. And each of these points has a measurable impact in terms of how we go about building these data sets, from what's going to be built, how it's going to be built, what layers will be included, how they'll be able to be integrated into existing operations and processes, and lastly, how we're going to be able to maintain these. And I think that's probably the most important part of this, is the concept of data maintenance, and more importantly, making sure that data can be exactly the same year over year, so that it's a repeatable approach and it's consistent with processes that are established based on that original data creation. So with that, I'm really excited to announce our partnership with Hexagon, the Hexagon Content Program specifically, where we are going to be building out a nationwide 3D land cover product based off of their 15 to 30 centimeter aerial imagery. So in terms of what this will encompass, I did bring this up at the annual meeting a few years, or in September of last year, but I'm excited to say that it's now been fully formalized, and it's already started the process of data creation. We decided to work with Hexagon because, one, the alignment in terms of large scale data imagery just seemed like a perfect fit for us. Specifically, they have data across the entire United States, including Hawaii, Puerto Rico. We're also going to be doing the 3 largest cities in Alaska. Unfortunately, we don't have enough data to do the entire state. But overall, the product itself is going to be complete by the end of summer, making it available for everyone to use before the end of this year. So, and I bring that up because in terms of data creation and speed of creation, this just demonstrates the capabilities of large scale data creation. So when we talk about 3D data can mean a lot of things. And I think it's very important to understand here, what we're creating is not necessarily a product that takes away the value from, a LiDAR point cloud. It's not going to be, if you're in a dense tree canopy, it's not going to be ground penetrating. This is an imagery stereo based product. So everything is derived from stereo imagery. And then in terms of the quality of detail that you're seeing on those buildings, I use this sample because it kind of demonstrates what you would effectively see from that. So you are still getting the multi-level buildings on there, and you're going to see a very high precision. In terms of how we're delivering that input, or how we're delivering that output, I should say, is going to be in terms of a relative Z point and an absolute Z point. So what you'll have is height attributed polygons on our buildings, trees, and bridges. So what we've taken is, effectively, these are similar principles to how height attributed data would be created through photogrammetry approaches, except we're leveraging kind of the power of automation to not only fuel consistency, but also fuel the scale as that. Further, as we kind of work through creating this product, one of the things that came very clear to us and clear to our partners and clients was they were looking for a unique tree layer. So that tree canopy layer is going to operate as its own independent layer, in the sense that you will feature overlapping polygons on that front, but you will still maintain the true positional accuracy of those impervious surfaces that lay through that. So in that visual there on the right, you can see there's some overlap in terms of the roads, even in terms of the lower buildings where that tree canopy comes to be. This is something that's going to be even more critical, especially talk about urban forestry, carbon sequestration, and a variety of different environmental impact solutions that are so critical nowadays, and where there's, more importantly, quite a bit of funding to support investigation into these concepts. Lastly, the concept of how we build this data enables us to update the data as soon as new imagery is available. So working alongside that Hexagon solution, what we can guarantee is that 3-year update, but also we can ingest additional imagery inputs from our clients to more frequently update that data. So when it comes to how this data is being created, so positional accuracy, I have an asterisk there. So what I'm talking about here is the relative accuracy. So in terms of positional accuracy, that is effectively based on what we see from the imagery. That being said, if you're looking at the XY coordination of most Hexagon products, at least for the base layer here, what you're seeing is a 2 times GSD for their absolute accuracy. So that gives you an input or an understanding of what that looks like. The vertical relative accuracy, what we're speaking about here, is the ground to building eave height. So effectively, for most use cases that we're discussing here, that's what's most critical. When we talk about the absolute height, looking at the sea level height, that varies, and you could be looking at upwards, you'd still be maintaining less than a 3-meter LE90 on those fronts. And there is also the caveat, as I mentioned previously, this is not a LiDAR-based product. So if we're talking about heavy mountainous, heavy forestry areas, you are going to see some impact on that front. And we want to be very open about that because we want people to understand exactly what we're talking about. Interpretation accuracy. So precision recall, these are essentially what we talk about false positives and false negatives. And effectively, those will represent less than 5% of classification. And I think it's important to put that into perspective because, sure, it's easy to understand a building is a building. But when you start talking about different land cover elements, whether it's, grass, bare land, forest canopy, and actually the interpretation accuracy of those, that's where you can run into some of those challenges. So how do we create it? So essentially what we're starting off with is a stereo, we're starting off with the stereo, the raw imagery. And from that, we're extracting a DTM to build that surface model, to build that surface layer. Once again, these are the exact same principles as what you would use in terms of photogrammetry approach. It's simply using the power of machine learning to be able to do this in a more scalable fashion. And where the uniqueness comes to Ecopia is essentially when we build out the actual DSM or the elevation product, we use every single building as a ground control point. So essentially, when we extract those building polygons, we're not extracting the roof, we're extracting the base of the building. And we do that by extracting at least 2 walls on the side of it. And by having that true ground positioning, we're able to essentially put forward a very precise elevation product. And from that elevation product, we're able to derive extremely high accuracy vectors. And those vectors, I put in summary there in terms of compact representation. What we mean there is essentially you're not going to have 100 points per structure in terms of if it looks like there's some alignment. It's going to be sharpened to facilitate data. So with that, I want to move directly into the concept of what we're establishing here, specifically when it comes to the NSGIC community. This presentation is tailored to the government community, to the various users of these data products. And one thing that we want to make very clear is we want to engage people on more than just a singular level. We want to engage federal, state, county to be able to procure this data through the same avenue so that everyone can leverage these data sets for their own benefit. So whether it's starting off with that standard high resolution vector map, as perhaps that may be the product that maybe your county is looking for, or you're interested solely in the impervious features, perhaps essentially it's just a derivative based off that foundational product. Or in the case of our federal partners, as we do quite a bit of work with NOAA, they're leveraging the 1 meter raster, which is effectively just a byproduct of that standard vector data. So overall, what we've been able to achieve by building these data sets out, not just as a service to a specific client, but to be able to meet the requirements of multiple users, is a product that can be tooled to everyone's requirements. But more importantly, it enables this concept of government sharing. And I think as we talk about the concepts of open data, the concepts of working together, concepts of data sharing, and minimizing overlap when it comes to data procurement, this model enables that to happen. So change detection. Change detection is something that is often referenced because it is a highlight of what people are looking for when it comes to geospatial data. One of the biggest challenges with change detection is the alignment of pixels year over year, especially when you're talking about large scales. Because Ecopia developed a solution in the 3-dimensional space, we can align raw imagery to our base product to ensure that we can extract and derive those insights rapidly for change detection. So what you'll see here is essentially a 3-year change of a region in California. And as you can see, there is significant change on the front. And what we've done here for our customer is label all buildings in terms of unchanged, new buildings, modified buildings, and destroyed or removed buildings. And this is something that can be done with relative ease. And although I'm only demonstrating the building footprint change detection here, this can be expanded to all the other land cover features. So whether you're looking for roadway changes, whether you're looking for forest canopy changes, all of this can be derived using the same solution. And a similar approach to this, if you think, as we talk about emergency response, post-disaster data creation. So Ecopia does quite a bit of work in the insurance domain. And through that, we're leveraging a lot of our building footprint products in post-disaster scenarios, especially in terms of the geocoded when you layer the geocoded solution on top of that. But effectively, what we're able to do with this product is understand changes within a period of 24 to 48 hours after we receive a fresh batch of imagery to be able to understand where these priority areas or where their most damage has occurred. Essentially, this maximizes a damage assessment with little to no resource in terms of on the ground. And when we talk about deployment strategies and understanding, where resources need to be allocated, I think this is a pretty fundamental topic, especially as, we're seeing more and more natural disasters happen each year. And similarly speaking, these solutions can be leveraged for things like forest fires, understanding the changes of where trees have burnt down. It's not just natural structures to understand the impact of it. So additional use cases. I don't want to dive too much in terms of all the different use cases that we're servicing, but I think it is important to understand these and understand how we've built these data sets to meet the requirements of a wide range of customers. When we talk about forestry management, whether it's simply an understanding of canopy, whether you're doing a carbon sequestration analysis, whether you're trying to understand the impact of urban sprawl, things in terms of Department of Fish and Wildlife, they're looking to understand the impacts in their natural areas. The canopy is increasingly important to them. Flood mapping. Essentially, when we layer our impervious surfaces with topographical maps, this has been proven to actually modify certain flood maps for certain regions. Specifically, one of our clients, the San Antonio River Authority, had to change their flood mapping guidance because of the outdated data that it was previously created on. And I think it's important to realize that these flood zones are not static. We're continuing to see change in where they are, and understanding and being proactive about these adapting scenarios is critical in terms of resource deployment. Utility mapping, broadband mapping. Broadband mapping, I want to spend a little bit of time on because this is something that has been discussed quite a bit recently, especially within the NSGIC community when we talk about the FCC building out these broadband maps. And Ecopia has been a big part of that conversation directly and through our partners, in the sense that having access to our data, including our geocoded data, enables a maximized utility of understanding where serviceable addresses are. So once again, what we're doing here is we're layering solutions on top of each other, but still maintaining the same foundational database. Similarly, when we talk about emergency services, whether you're looking for access points to residences, understanding the level of floors and structures, the emergence of an integration of next generation 911 as everyone continues to discuss, requires more robust information. And more importantly, it needs to be up-to-date information in order to service these requirements in the long term. And the last one is property assessment. So when we talk about property assessment here, what we're talking about is understanding these change in structures, understanding the change in buildings, but also things like understanding perhaps someone built a swimming pool that wasn't necessarily permitted. These are the elements of leveraging large-scale data extraction that enable you to do a rapid analysis and to essentially provide guidance for these fundamental tools, whether, like I said, it's at the municipal level, county level, state level, or all the way up to the federal level. So to provide some examples of some of our customers, so at the annual meeting, Nate Harold and I from the NOAA community, the Office of Coastal Management, discussed about how they've been leveraging our data. And I think it's important to understand this and reiterate this, because what we've been able to do with this is leverage our high resolution vectors and derive the 1 meter data sets that are critical to the CCAP program, but also look at integrating additional partners. So whether that's partners at the state level who are looking for the high resolution data, but may also have some utility of that 1 meter data set. By bringing those two together, we can operate under the same contract and facilitate the procurement of these data sources. So up to date, we've done over 40,000 square miles of data extraction for the CCAP program specifically, including both just impervious solutions and some full land cover projects. The utility of this data set, as you can imagine, and is very significant. And one of the reasons why we like to support this is, as I mentioned, we're looking for ways to bring government together. And obviously we have, as a company, we're very interested in controlling the intellectual property of our high resolution vectors. But what we found is making a compromise to work with the need for open data and the requirements to support these initiatives with a balance to also protecting our own intellectual property on these data sets. And this is something that we're continuing to expand on, continuing to develop, and continuing to have more and more conversations, even with several members who are most likely attending this webinar. And we look forward to continue those discussions. And when we talk about the difference in quality of data, we talk about what previously existed to what we're at now. And I think it's very important to not just understand this as a picture of, yes, this is 30 meter to 1 meter, it's very different, but also understand what this new technology enables, what the technology at Ecopia has been delivering and continues to deliver is enabling these high resolution data sets to be created and offered at a price point that was similar to creating these elements at large scales, 10, 15 years ago at a coarse resolution where you can't really extract the kind of detailed information that you're looking to. Similarly, just in terms of, and this is still a derivative-based product, when we talk about leveraging machine learning and computation to extract features through automation, a lot of people think, okay, there's a lot of people talking about this. What really makes the difference? And ultimately, by us creating these data sets at a minimum of a 30 centimeter vector vector-based extraction is we can guarantee a more granular data extraction. Specifically here, it's important to look at the impervious layers. So what you're seeing here is extraction of driveways, sidewalks. You're getting that granular information of a more true structure, which is really important as you start to understand and make more critical decisions based on these higher resolution data sets. The next sample I want to talk about is not necessarily at the state level, but the reason I bring it up because it's important to understand the granularity of what the other side of the data extraction. So we just talked about looking at a 1 meter data scale, but now we're looking at, this is more on the 6-inch, 15 centimeter data scale. And this is moving into the concept of planimetric data extractions. So we've been working with the city of Detroit for a few years, and the city of Detroit, like many other cities, has imposed a taxation on properties based on the level of impervious surface within their unique parcels. And effectively, what they were able to achieve by leveraging our solution is taking that primary base product that we've been developing, but then we expanded it and looked and added more detail for them to essentially understand not just impervious at a high level, but understanding paved, unpaved structures all the way through driveways, parking lots, roads, sidewalks. And through that information, they are able to have a cost-effective solution that they can maintain year over year. So this is something that we're doing for them on a yearly basis. And when we look at what that actual output looks like, is you can actually understand the delta of where these changes are occurring. And when it comes to property taxation and actual taxation and critical decision making, it's very important that you can understand where these changes lie, especially when you're talking about a direct interaction with the people who are effectively funding the project. And when taxes are involved, you have to make sure the data is right. So ultimately, what we have done is we're building out a solution. We're building out a solution to meet the requirements of government, of insurance, of telecommunications, something that can be consistently available off the shelf, on-demand content that changes the way that we think about data creation. It's no longer that you need to just have a serviceable solution that is created specifically just for you for one-time data creation. This is something, and it is something that is available off the shelf. We've already started data creation on the West Coast of the country, and we will be moving through, and as I said, it will be finished by Q3 of this year, which means effectively these products will be made available to all of our customers by the end of this year. So when we talk about these different products, it's not just the 3D land cover product that's available, it's these different layers. And as we work through these layers, there's different utility to different clients, which is where it comes into the equation of our partnership model and why we want to bring together multiple groups to be able to utilize this data. In terms of updating, so right now we have aligned with the Hexagon Content Program, but that isn't to say that we aren't doing more. So we have specific clients who have their own imagery cycles as well. And so essentially for them, we're guaranteeing yearly updates on these data products. So what we're doing through this is essentially not just looking at a one-time data purchase, but moving into the subscription-based pricing model. And as we move into these subscription-based product pricing models and having these products, essentially we can move into having these products delivered as a as essentially a general operating expense and something that can be routinely and consistently relied on for your relevant departments and groups. So effectively, I've streamlined through this. We're very, very excited about this solution and this product. You guys are the first group to kind of hear about this. And the reason why we wanted to do an effective soft launch with this group is because as we create this data, we also want to understand perhaps there's additional inputs that can be derived for for your relative groups or states or whatever it may be, and incorporate that into the product. So with that, I zoomed through this, so we do have plenty of time. I would love to take any questions that you may have. And if you don't have any questions now, I could look forward to engaging with you guys after as well.
Thank you, Brandon, for that wonderful presentation. We have a question from Jean in our chat, and just a reminder to everyone, if you do have a question, please put it in the chat box. I will gladly read it out loud for Brandon. So I'm going to start with his. He has two questions. The first question is, how can Ecopia AI pairing support processes associated with address validation as part of an emergency service use case?
Sure. So effectively, there's a product that I didn't necessarily mention here, but essentially Ecopia maintains a geocoded address product that has been cross-validated across multiple data sources. And what we've built for that is an alignment to all of our building footprints across the nation. So as I mentioned, we started off by creating the building footprint product, and through that, we've expanded it to it. So in terms of a cross-validation or parents to support, a validation of addresses, effectively there's obviously going to be a limit of what you can do solely based on geospatial data. However, having the ability to coordinate between buildings, parcel information, and understanding a coding based on those primary residences should enable you to get 95% of the way there. There's always still going to be a requirement to have an on-the-ground validation and a consistent kind of update cycle. So when it comes to our geocoded product, most of our customers have access to our team, which enables us to have a feedback window where we can directly integrate any sort of adjustments as they may be needed.
And then his second question was, can Ecopia's classification processes identify crop types supporting regional agricultural management?
Historically, Ecopia has not focused so much on the crop type distinguishing factors. Effectively, what we focused on is more the base layer data creation. So we can do in terms of agricultural farmland boundaries. However, we have not gone the extra step in terms of building that actual segregation of different types of fields and crops and whatnot. And the reason we do this, as I mentioned, what we're doing is a creation of a standard 3D base layer. We recognize that there's obviously still going to be some additional input that is required from unique groups in order to make that product the full service, requirement to their needs. And by having that base layer, though, essentially what you do is you get 90% of the way so that you can maximize the utility of your own team.
We have a question from Tony. So none of the products provide access to the underlying DSM that was created as a raster product?
So currently the DSM is not necessarily being made available as part of the solution. That being said, there are still ongoing discussions in terms of how we're working with Hexagon in the sense of making that DSM available alongside those vectors. But as I mentioned, this is effectively a soft launch. This is not, we're not necessarily, it hasn't been publicly announced yet, so there are still a few details to be released. But as it stands right now, the vectors will not be made available with that DSM product.
And if anyone else has any more questions, please put them in the chat now. And give it a minute.
No problem.
So is the we have two questions. I believe one was from Tony. So the DSM is a Hexagon product?
No. So the way that we create our DTM and DSM is a proprietary solution developed by Ecopia, and it's based, as I mentioned, when we create that DSM, we're using our building footprints as effectively unique ground control points for each, essentially for the DSM. That being said, because we are basing it off of the Hexagon solution, there will be an alignment to the Hexagon DSM product.
And we have a question from Gar. How large is Ecopia in regards to employees and the office locations?
Ecopia is 50 people, and we are based in Toronto, Canada.
All right, it looks like that was our last question. If anyone else has any, please put them in the chat box. In the meantime, I want to thank Brendan and Megan once again for coming on today and giving that wonderful presentation. And once again, thank you to all of our NSGIC members for attending today. We are so happy you are here. And any last words, Brendan?
No, I just wanted to say thank you all again for taking the time. As I mentioned, if you do have any questions, please feel free to reach out. I'm more than happy to take the time to actually give you a demo of the data itself in perhaps a region near you so that you can get a firsthand look at what those vectors look like. But there will be a lot more news as time rolls out here. We're very excited about this partnership and this development of this content. And we look forward to continue exploring these opportunities with the NSGIC community.
Wonderful. Well, thank you so much again, Brendan and Megan, and thank you to everyone attending today. Looks like we will give you back part of your day, so have a wonderful day, everyone. Thanks again, and you've got a couple thank yous, Brendan, from everyone in the chat as well.
Perfect. Thank you so much. Thanks,
Right.
Amy.
Thank you. Everyone have a great day. Goodbye.
Bye-bye.